Still on fraction. So how do we add fractions? When fractions have the same denominator, the answer is very simple. We simply add the numerator. 3 plus 1, 4. So the answer is 4. They have the same denominator. 1 plus 2 is 3. So the answer is 3 over 7. Here they have the same denominator. 3 plus 4, that is 7 over 10. As simple as that. We can still break this one down because 2 is common. 2 in 4 is 2. Say 4 in 4 is 1. 4 in 8 is 2. But if they do not have the same denominator, we cannot just add. So one of the mistakes some students can make, you can say 3 plus 4, then 5 plus 15. This is wrong. You can only add if they have the same denominator. Now that they have different denominators, what can we do to make it the same? Now there are 3 cases involved. If one number can divide the other, one of the denominator can divide the other. So 5 in 15 is 3, right? Divide the numerator here by 3. This also by 3. At the end of the day, 9. 19. 1. As you can see, they now have the same denominator. So 9 is 10, so the answer is 10 over 15. Break down, can go in both 3 over over 5 in 10 is 2, 5 in 15 is 3. So the answer is 2 over 3. That. Same goes for the next one. So 3 in 3. So multiply this one here by 3, multiply this by 3. So we will be left with what? 9 plus 4 times 3, 12. 3 times 3, 9. The same denominator. So 12, 2 plus 12 is 14. So that's 14 over 9. It's improper fraction. In mixed fraction, 9 14 is 5 over 9. That. For the next one also, divide 12. So 12 in 2 places. So multiply 2 by 2. You know this side by 2. Our aim is to make this number a bigger number. So from here we're going to add 1 over 2 plus 10 over 12. Say the answer denominator, so just add 1 plus 10. So the answer is 11. Now in this case, they do not have the same denominator, yes, but one number cannot divide the other. So in fact, they are relatively prime. They have no common factor. So if you have a question like this, whereby they have no common factor, the short is that nothing can divide. There is no number that can divide both 4 and 3, 7 and 5, 2 and 3. They are all relatively prime. So what are you to do? Look at this shortcut. 3 times 9, 4 times 4. Then we'll do 4 times 3, 12. So what's the answer? 13 over 12. A mixed fraction number 12. Same thing goes there. There's no about 7 and 5. 6 times 5, 30. 7 times 2, 14. 7 times 35. I'm going to add what? 4 over 35. We'll use one number. That will be 11 over 35. Yes. Is that 11? 44, no, not 11. 44 minus 35. We borrow 1 here, this is 14. 14 minus 5 should give us 9. So that's 9 over 35. That's the final answer. We do the same thing for this. They have no common factor. So 3 times 1, 3. 2 times 2, 4. 2 times 3, 6. So that's 7, 6. Number 6. The numbers are not the same. So not this case. One of them cannot divide the other. Not this case. Then they have common factor like this one. These two can divide this. So they have a common factor. If they have at least one common factor, meaning if there's a number that can divide 12 and can also divide 8, so we cannot use any of these methods. What can we now do? We have to use the LCM method. But the method that we're going to use here now for this case, we can use the method for every other ones here. So what's the method? We look for the LCM of 12 and 8. So what is the LCM of 12 and 8? Solve it and let me know the answer. So the LCM of these two is 24. So what can we do here? How many 12 can you see in 24? 2, right? So multiply the numerator by 2, the denominator also by 2. How many times can 8 go in 24? 3. Multiply this one by 3, this one also by 3. So by doing so, the fractions will have the same denominator. So 5 times 2 is 10. 12 times 2 is 24. 3 times 3 is 9. 8 times 3 is 24. Since they now have the same denominator, we just add 10 plus 9, that's 19 over 24. Or better still, it can be faster this way. The LCM of 15 and 20 is what? So solve it and let me know the answer. 15 and 20. We've done that in our last class. So that is 60. If you do it, you should get 60. So instead of multiplying, instead of doing, okay, like what I did here, 15 in 60 is what? 4. We now multiply this one by 4, this one by 4. 20 in 60 is 3. By 3 by 3. Instead of doing that, you can just write something like this. Then we write the LCM here. So we now ask, how many 50 can we see in 60? Meaning 60 divided by 15 is what? That's 4. Then the 4 multiply 2 here. So you have 4 times 2. How many 20 in 60? 3. That 3 multiply this 3 here. So you have 3 times 3. So what I have here, 4 times 2, 8. Plus 3 times 3, 9. Over 60. So 8 plus 9 gives 17. Over 60. Okay, for the last one, 1421, what was the LCM? Please do it and let me know the answer. If you solve it, you should get, you can solve it for, solve it, what's the answer? If you solve it right, you should get 42. So, how many 14 can we see in 42? That is 3. Then 3 multiplied is 7, that's 3 times 7. Then plus, how many 21 can we see in 42? That is 2. Then 2 multiplied is 10, 2 times 10. So here we're having 21 plus 20 over 42. So the final answer is 41 over 42. That's the same method we use here, just in a different manner. So that's the end of this aspect. If we know addition, we know subtraction. So let's do a case whereby we have subtraction and also mixed fractions. Now look at the following question. So here, this subtraction. But what do we have here? We have mixed fraction. Whenever we have mixed fraction, there are many ways of doing this. But in order to play safe, the best is convert to improper. 3 times 2, 6. 6 plus 1, 7. It means this actually is 7 divided by 3. Minus 9 times 1, 9. Plus 5, that's 14 over 9. So which method are we going to use? Since 3 can divide 9. So, and 9 over 3 is 3. So I'll multiply this one by 3. This one by 3. So 7 times 3 will give us 21. 3 times 3 will give us 9. Minus 14 over 9. Because they now have the same denominator, we can easily subtract. So 21 minus 14 will give us 7. So the answer is 7 over 9. Okay, next one. Let's convert to improper. 4 times 2, 8. 8 plus 3, that's 11 over 4. Plus 5 over 16. Minus 4 times 3, 12. Plus 1, 13 over 4. If we have more than 2 fractions, the best is just use the LCM method straight. So the LCM of 4, 16, and 4, if we do it, you get 16. We don't need to even solve it. Since 4 can go in 16, the LCM of 4 and 16 will be 16. So 4 in 16 is 4. Then multiply 4 by this 11. 4 times 11 is 44. Then we have plus. 16 divided 16, that is 1. 1 times 5, 5. Then we have minus. 4 in 16 is what? 4. Then 4 times 13 will give us 52. Then we can add. 44 plus 5 is 49. So we have 49 minus 52 over 16. 49 minus 52 impossible because 49 is smaller. So we swap. We now do 52 minus 49. But anytime you swap, you write minus first. So 52 minus 49 will give us what? 3 over 16. So that is the final answer. Okay, next one. we have 4 fractions. Don't panic. I have 4 over 5 minus 10 times 1, 10, plus 3, 13 over 2, plus 50 times 2 is 30 plus 1, 31 over 15, then minus 2 over 3. So we can look for the LCM of 5, 10, 15, and 3. The shortcut, 3 can go in 15, so I'll cancel out 3. 5 can go in 15, I'll cancel out 5. So I'll only look for the LCM of 10 and 15. And that will give us 60. Sorry, 30. You can also decide to use the traditional method. You get the LCM to be 30. Then 5 in 30 will give us 6. So the 6 multiplies the 4. That's 6 times 4. Then we have minus here. 10 divides 30, that's 3. Then 3 multiplies 13, that's 3 times 13. Plus 15 in 30 will give us 2 multiplies 31, that's 2 times 31. Minus 3 in 30 is 10, multiplies this 2. 10 times 2. So note, if we have something like this in mathematics 2 and 3, it actually means what? 2 multiplies 3, which is 6. So 6 times 4 will give us 24. 3 times 13 give us 39. 2 times 31 will give us 62. 10 times 2 give us 20 over 30. So, like I told you, if you have addition or subtraction, just go from the left to the right. So 24 minus 39 is not possible. So we'll put minus, then we'll do 39 minus 24. And that is 15. Then 62 minus 20 will give us 42 over 30. If you are adding two numbers and they have different sign, we have to subtract. So we are going to do 42 minus 15. And that is 27. What would be the sign? Bigger number. 42 is bigger than 15. So, and 42 is positive. So it is what? Plus 27 over 30. But you don't need to write the positive sign. And that's the end. With these examples, you should be able to add and subtract any fractions, whether we have 2, 3, or 5 fractions. So now the next operation is multiplication, then division. Suppose I have a fraction a over b, however another fraction c over d. So if you have to multiply the fractions, there are 2 things involved we have to know. First, these 2 fractions have to be in their simplest form. Then after that, b and c can cancel each other. Then d and a can also cancel each other if there is a common factor. But if there is no common factor at all, we are going to multiply a and c to give us a times c. Multiply b and d to give us what? B times d. Let's give examples. Now consider this example. Before you do anything, ensure this is in the simplest form and this. So when you check 4 and 14, what do you have in common? 2 is common. So divide 4 by 2, we get 2. Divide 14 by 2, we get 7. So times, we come here. Is there any common factor? No. There is no number can divide 21 and 10. So we leave it as 21 times 10. Then after, we will now see. Within these 2, do they have any common factor? These 2 also, do they have common factor? Between 7 and 21, is there common factor? Yes. Why? 21 is 7 times 3. So meaning, I can say 7 here, 1. 7 in 21 gives 3. What about between 2 and 10? Yes, something is also common between 2 and 10. Why? Because 10 is even number, 2 can go. So we can say 2 in this 10 gives 5. 2 in 2 gives 1. Then after we cut, we cannot follow this rule. We multiply all the numerator, then the denominator. So the answer here becomes 1 multiply 3, that's 1 times 3. Then 1 multiply 5, 1 times 5. So 1 times 3, 3. 1 times 5, 5. So the final answer is what? 3 over 5. So for this part, we have 3 fractions. So let's convert to improper first. 1 times 3, 12. 12 plus 1, 13. So this is 13 out of 4 times 7 out of 26 times 3 out of 14. So from here we can see these 2, nothing is common, nothing is common, So we can start comparing. What do you have up? That's a common factor what we have done. So 26 is a factor of 13 because 13 times 2 will give us 26. So we can say 13 here 1, 13 here 2. What else? 7 and 4, 14 rather. So what is common? 7 is common, so we can say 7 here 1, 7 here 2. What else do we have that is common? So numerator we have 3. Here no multiple of 3, so we are done. So what's the answer? We multiply all the numerator. 1 multiplied by 1 times 3. Then 4 times 2 times 2. So 1 times 1, 1 times 3, 3. 4 times 2, 8 times 2, 16. So the answer is what? 3 over 16. Multiplication is easy. Let's take another one. Now, let's consider this. We have 4 fractions, so it doesn't matter. Let's convert the mixed to improper. So from here, 3 times 2, 3 times 1, 3, plus 2, 5. So this is 5 over 3. Multiply by 9 over 15. Multiply by 2 times 3, 6 plus 1, 7 over 2. Multiply by 12 over 21. So let's see common factors. Now from here, 3 and 9, we have common factor here. 3 here 1, 3 here 3. Then 45 and 15. 5 here 1, 5 here 3. So what do we have here? These two, is there a connection? Yes. 2 here 1, 2 here 6. For this, is there a connection? Yes. 7 here 1, 7 here 3. Is there a connection? Yes. We have 3, 3. Perfectly the same thing. So we can still cancel all. So it's not going to be rough. Let's write them out. So here we have 1 times 3 times 1 times 6. Everything over 1 times 3 times 1 times 3. So what happens here? 1 and 1 cancel each other. 3 and 3 cancels each other. 1 and 1 cancels each other. So we are left with 6 over 3. And here 2 is still common. Sorry, 3 is common. 3 here 1, 3 here 2. So what's the answer? 2 over 1. Anything divided by 1 is that thing. Let's now move to division. Division and multiplication, they are brothers. Suppose I have A over B divided by C over D. What happens here? It is easier to work with multiplication than division. So whenever I have something like this, always change division back to multiplication. So I have A over B. I'll turn this one towards times. But whenever you change division to multiplication, the fraction will what? Swap. Numerator becomes denominator, denominator becomes numerator. So this becomes what? D over C. In Yoruba, we say O sorikodo. So we can call the process sorikodolization. That's macaronism. Let's leave that apart. Whenever we turn division to multiplication, the fraction sorikodolize, or we can say the numerator and denominator are swapped. For example, consider these examples. So here I have 21 over 10. I'll turn this division to multiplication, then this turns to 4 over 14. Then after this, we can go on with the normal rule for multiplication. So first, what do you have in common here? Nothing. Here something is common. What is that? 2 is common. 2 here 2. 2 here 7. So this is 2 over 7. What is common again? 2 is common for 10 and 2. So you can say 2 here 1. 2 here 5. What is still common again? Something common? Yes. 7 and 21. So you can say 7 here 1. 7 here 3. So when you check the numerator, we have only 3 and 1. 3 times 1 is 3. 5 times 1 is 5. So the final answer is 3 over 5. Now let's come down here. So we have 26 over 7. Okay. Let's turn this one to improper first. 4 times 3, 12 plus 1, 13 over 4 times 3 times 4, 12 plus 2, that's 14 over 3. So this becomes 26 over 7. Then we'll turn this division to multiplication. Then up to this one, it's equalized. So 4 over 13 times 14 over 3. So let's see what we have in common. So if you check 7 and 14, 7 is common. So 7 here 1, 7 here 2. What again? 13 and 26. So 13 here 1, 13 here 2. What else do we have? I think there's nothing more. At the numerator we have 2 times 4, which is 8, times 2, which is 16. Divided by 1 times 1, 1 times 3, 3. So that's 16 over 3. In mixed fraction, we can see 3, 5 places. That's 15. So that is the answer. For division, whenever you have what? Division, turn it to multiplication, and the fraction will solely equalize. Something is obvious here. Minus and plus, they go hand in hand, they are friends. Multiplication and division, they go hand in hand, they are friends. And I also use brackets this time around. If I have 2 bracket 3, it actually means 2 times 3. So brackets. So we can have a question whereby all these signs will be there. So, and in that case, if we didn't follow a certain rule, we'll be getting different values. For example, if I ask you, very quick, 2 plus 2 divided by 2, what's the answer? In 3 seconds. 2 plus 2 divided by 2 in 3 seconds. 1, 2, 3. What's your answer? Most likely you say the answer is 2, and which is wrong. The answer is actually 3. Why? We have to follow a rule. We call it the rule of PEDMAS, or we call it BODMAS. In that rule, we always divide first. Or let's say we consider these 2 before this. We consider division before addition. So what is 2 divided by 2? 1. So what is 2 plus 1? 3. So if you ask any student, most students, oral question, 2 plus 2 divided by 2, they will tell you 2. But the answer is actually 3. Because we have to divide first before adding. That will take us to the rule of BODMAS. But instead of using BODMAS, I prefer PEDMAS. P is for parentheses. E is for exponent in case we have power. D is division. M is multiplication. Then we have addition and subtraction. So let's focus on the last 4. According to the law and rule of BODMAS, whenever we have division, we have to turn it to multiplication. Then after doing that, we cut to the last word for a bit fraction. Then we do addition and subtraction together. Some people say you add first before subtracting, but in that case, you might make a mistake. For example, look at this. 7 minus 5 plus 3. Following the rule of BODMAS, some students will say, we add before subtracting. So what are they going to do? They say this, 5 plus 3. So 5 plus 3, they will write as what? 8. So that would be what? 7 minus 8. In this case, the answer is impossible. Then 8 minus 7 is 1. So minus 1. This is wrong. Why is it wrong? It is true that we can add first. But this negative is for 5 alone. So we are not doing 5 plus 3. It's actually minus 5 plus 3. So minus 5 plus 3 will give us minus 2. So if you have 5 minus, so minus 5 plus 3 gives minus 2. Then 7 minus 2 now gives us 5. The correct answer. But we can avoid all this error by doing what? Just go from left to right straight. 7 minus 5, 2. 2 plus 3, 5. So that's why I said addition and subtraction can be done simultaneously. Just move from the left hand side to the right hand side. If you have division, turn it to multiplication. And focus on the parentheses, or we call it the bracket. Then if you have power, you have to do the power first before any other thing. For example, if I have 4 squared divided by what? 2. So don't say, okay, 4 divided by 2 is 2. So the answer is what? 2 squared. That's 4. Wrong. We must do this order first. So 4 squared is 16. Divided by 2 will now get 8. Although most questions you see in junior level or in primary school will not involve power. So we are not doing it exponent. That's why most times the acronym used is what? BODMAS. where B is the bracket, where O is order, D is what? Division, multiplication, addition, subtraction. Let's take some examples under BODMAS or PEDMAS. Now look at this question. We have 3 plus 2 times 6 divided by 2 minus 1. So what are you meant to do first? There's no bracket, there's no order, so we start with division D. So focus on the division. So our advice, go and look for where you have division, then put it into bracket this way. Then we continue. So that's 3 plus 2 times 6 divided by 2 is 3. 3. Then minus 1. So if there is no more division, then focus on what? Multiplication. Where do you have it here? 2, 2, and 3. Then we'll now do 2 times, then is 3 plus 2 times 3, 6 minus 1. What next? Addition, subtraction. Just go this way. 3 plus 6, 9. 9 minus 1, 8. So the final answer is 8. I gave an example involving whole number. Let's now give an example involving fraction. Look at this question. I'm taking it high. So do not panic. What's the first rule? Look for where we have division first. Or before that, when you have mixed fraction, first convert everything to improper. 2 times 1, 2 plus 1, 3. This is 3 over 2. Plus 3 times 2, 6 plus 1, 7 over 3. Times 5 over 12. Divided by 15 over 2. Minus 2 times 2, 4 plus 1, 5 over 2. What next? Look for where we have division. Division first. So we have to deal with this first. So we have 3 over 2 plus 7 over 3. Then if you have division, what do? You turn the division to multiplication. The 2 goes up, 15 comes down. Minus 5 over 2. What next? We have to deal with what you have in the bracket first. From here, 2 here 1, 2 here 6, 5 here 1, 5 here 3. Let's move on. So this becomes what? 3 over 2 plus 7 over 3 times 1 times 1, 1. 6 times 3, 18. Minus 5 over 2. So as you can see, no more division. If there is no more division, we'll go to multiplication. And where is it? This is multiplication here. So that's the next thing. And as you can see, we have no common factor here. So we'll just multiply. So this is 3 over 2. Plus, not can divide here. 7 times 1, 7. Then 80 times 3, 54. Minus 5 over 2. What next? No more multiplication and division, so we can just add. In this case, the LCM is going to 54 because 2 can divide 54. So we have 54 here. So 2 in 54 is 27, and that will multiply 3. That's 3 multiply 27. Then we have plus. 52 in 4 is 1. Then 1 multiply 7. Then we have minus. 2 in 54 is 27 times 5. 27 times 5. From here, we can expand. So 3 times 27 is 81. 1 times 7 is 1. 27 times 5 is what? 135 over 54. 81 plus 7 is 88. 88 minus 135 over 54. So what next? 88 minus 135 is impossible, then we write minus. 135 minus 88 will give us 47 over 54. And from here, there is no common factor. So that will be the final answer. Let's give another example, a tougher one, perhaps the one with bracket. Look at this question. Do not panic. The first rule in mathematics, calm down. Just focus. First, do you have brackets? Yes. So this bracket, you have to know the answer. You have to know the answer to this. Then we have division here too. So these two, you have to connect them together. This off, you can replace with times. So what's the first thing? We can first convert everything to improper fraction. So I have 1 over 2. Up means times. 3 times 3, 9 plus 1, 10 over 3. Then plus 1 over 2 divided by 1 over 3. Everything over 2 times 1, 2 plus 1, 3. 3 over 2 divided by 1 over 4. Plus 3 over 2 divided by what? 1 over 8. What next? Let's turn all the division to multiplication. Here we have division here. So this one, we'll do this one first. So what are you going to do here? So this is 1 over 2 times 10 over 3 plus 1 over 2 times 3 over 2, 3 over 1 rather. Then over here we are going to have 3 over 2 times, then we have 3 over 2 times 8 over 1. So we can continue. Now there is no more division, so we do all multiplication first. So here we have this multiplication here, so we are going to do this, then with this. So you don't need to separate them out so that your work will neat. You can continue this way. From here, the first thing is for us to cut. Can we cut? Yes. 2 here 1, 2 here 5, nothing more. Nothing can be cut here. 2 here 1, 2 here 2, 2 here 1, 2 here 4. So with that, what are you going to have? So 5 times 1, 5. 1 times 3, 3. Then plus 1 times 3, 3. 2 times 1, 2. Divided by 3 times 2, 6 over 1. Plus 3 times 4, 12 over 1. So what next? See, you see this long division? I can replace this. I can write this as 5 over 3 plus 3 over 2, the numerator. Then 6 over 1 plus 12 over 1, the denominator. Then for this, as for this, it is this. Then I can replace this one with what? This. Then here, no common factor. So 2 times 5, 10. 2 times 3, 9. 3 times 2, 6. Divided by, since they are the same denominator, we can just add numerator. 6 plus 12, 18. What next? 10 plus 9, 19 over 6. Then this one times, when you turn this one to times, what happens? So the codalization 1 over 18. Is there anything I can cut? Nothing, because 19 is the prime number. So 19 times 1 is 19 over 6 times 18, 108. That is the final answer. Just do it step by step. Let me scare you with this question. But like I said, the first rule in mathematics, don't be scared. Don't be scared. So, if you have a question like this, start from the what? The bottom. So, we can bring this one out. 4 over 5 plus 1 over 5. There's the denominator, that's 5 into, just add 5, which is 1. So it means everything in here is actually 1. So let's clean this and put 1 there. What is 5 over 1 is still 5. So you can just clean this. 3 plus 5 is 8. So everything here is 8. Then we have 4 over 8. 4 over 8. 4 here 1, 4 here 2. So it means everything here is what? 1 over 2. So we can clear the 4 over 8 and replace it with 1 over 2. What next? 3 minus half. 3 minus 1 over 2. So what you can just put 1 here. What the LCM? 2. 1 into 2 times 3, 3. Sorry, 6. Minus 2 into 1 times 1, 1. 6 times 1, that's 5 over 2. So it means we can replace everything here by what? 5 over 2. Yes, what next? The whole of this. We have 2 divided by 5 over 2. I can write as 2 divided by 5 over 2. Same way. This over 1. So that's 2 over 1 times 2 over 5. So equalization. 2 times 2, 4. 1 times 5, 5. So it means everything here is what? 4 over 5. You can replace everything there with 4 over 5. What next? The whole of this. So that's 3 plus 4 over 5. Shortcut in adding a whole number and fraction. We just apply this together. 3 times 5, 15 plus 4, 19. So everything is directly 19 over 5. Count it normally. So we can replace everything here with what? 19 over 5. Then we can finish this up. This also something as what? 3 divided by 19 over 5. This something as over 1. And this was 3 over 1 times 5 over 19. 3 times 5, 15. 1 times 19, 19. As simple as that. Now, as you can see, I gave this question for a reason. To know that mathematics is not difficult. Sometimes a question might look difficult, but you should have joy in trying to find solution to that problem. So no matter how difficult the question is, as far as it's not beyond the scope of what you need to know at that particular level, you can do it, you can solve it. Just start from what you know, do what you can do, and you see yourself approaching the results. Let me scare you again with this question. Are you scared? Beat your chest that I can do this. Do not panic. What I meant to do first? First rule, turn all the improper, so all the mix to improper. Let's do that very quick. You don't need to separate. So that's for this. Note, this one alone has division. So meaning we have to do each part first. This must be done first. Everything must be done first. Before now go to plus the next one. So convert everything also to improper. Then divided by, same thing here. Turn everything here into improper. This first line should not give you any issue. Now, here, check, where do you have division? We have division here, we have division here. So what I meant to do, convert to multiplication. So if I turn this division to multiplication, what happens? This 5 over 4 turns to 4 over 5. If I do the same thing here, if I turn this division to multiplication, this 1 over 4 turns to what? 4 over 1. Then we are good to go. What next? What we just have is addition of fractions. So the shortcut here, 3 times 3, 9. 2 times 6, 2 times 8, 16. Then 2 times 3, 6. That's why in the numerator. Then divided by denominator. 2 times 8, 16. Then we have minus. 3 times 3, 9. 3 times 2, 6. So what we have here is for this part, this first part. Then plus, let's say everything for this one too. For this one, the LCM is 4. Is 4. So 2 in 4, 2. 2 times 5, 10. Then we have this minus here. 4 in 4, 1 times 5, 5. Then we have the division. Then the denominator. For the denominator, we can cancel here. Why? 2 here, 1. 2 here, 2. 5 here, 1. 5 here, 1. So what do we have there? We have 1 times 2, 2. Over 1 times 1, 1. Then we have divided by, let's do the same thing here. Here they have the same denominator, so we just write 2. Over 7 minus 5, 2. Then we have it divided by, So for this one we have minus, we have times. So we are going to do the times first. So 2 here 1, 2 here 2. So the first half we have here should be left undisturbed. Then we have what? Minus. 1 times 2, 2. 1 times 1, 1. But note, everything here has to be done together. Don't make that mistake. What next? 9 plus 16 should be 25 over 6. Then times 16 minus 9 should be 7 over 6. Sorry, divided by its division. That's for this one. Then plus 10 minus 5 is 5 over 4. Divided by 2 over 1. Then plus 2 over 2. Divided by, everything here will give us what? The LCM here is 2. 2 into 1. 1 times 1 is 1. Then minus 1 into 2 is 2. 2 times 2 is 4. So that's 1 minus 4. And 1 minus 4 is what? Minus 3. So you can print this one and write minus 3. What next? We are still in the bracket. We turn the division to multiplication. This is 25 over 6 times 6 over 7. This is 5 over 4 times 1 over 2. Oh, this divided by 2 over 2 times 2 over minus 3. What next? Let's see what we cancel. Hello, hi. So, over here, do you have anything I can cancel here? Nothing. Over here, yes. Hello, hi. So for the first one here, we have 25 over 7 left. Plus 5 over 8. divided by, up here we have 2, down here we have minus 3. So what next? We have plus and division. You do division first. 25 over 7 plus 5 over 8 times minus 3 over 2. So from here, do we have anything that can cancel? 2 cannot divide 3, cannot divide 5, cannot divide 25. 8 and this, nothing common. Same goes for 7. So since there's nothing common, we just multiply directly. 25 times 5 is 125. 125 times 3 will give us 375. But we have minus here, we'll put it here. Then 2 times 8, 16. 16 times 7 will give us 112. As you can see, mass is very interesting. So see how scary the question is, see this answer. But we can still write this one, we can express as a mixed fraction. So, and we've done that before. So 112 can appear in 375 3 times. Let's put this minus out first. So 112 in 375 should be in 3 places. Because if we do 112 times 3, let's see what we're going to get. So that's 336. So if you now remove 336 from 375, we'll get the remainder. So that's just 75 minus 36. Bottom one here is 15, this becomes 6. So 15 minus 6 is 9. This is what? 39. So that's 39 over 112. That's the final answer. Recall, numbers are either real or complex. We cancel out complex. Real are either rational or irrational. We cancel rational. Irrational are either integers, whole numbers, or fractions. We are done with integers. We are done with fraction. The next is to do application, which is where mathematics starts for a level. So, introduction to mathematics ends here. So now we are moving to application of what we've done so far. Expect that from the next video. Thank you very much.